that feels nice.
Yeah, so this attic was blasted out by 6 companies in 1931, and it was blasted out to be a ventilation attic so that they could vent these diversion tunnels. Right down there, guys, go downstairs. I'll be down there when I get all 10 of you counted.
Nice.
And that small group is
I love it. I had 6, I had 8, now I got 10. I had 57 one time. I'm like,
Oh my gosh.
yeah, they were no fun at all.
There's not a limit.
I got a bad wheel, man. I gotta go slow.
Actually, that one was a challenge because we had about 8 different languages. And so that's just the way it is sometimes. You just suck it up and drive on. Take pictures, guys, and when you're done, let me know and I'll go ahead and start. No, we'll see the generators on the next stop, but this is the pipe that feeds it.
Oh.
Are the 2 open tunnels still open? That they closed off?
All 4 of them, the yellow part, so the yellow part of the diversion tunnels aren't used anymore.
But are they still there? I mean, is it still open? I mean, is
No.
it still a tunnel?
It is, but they got concrete plugs and
Yeah.
steel bulkhead doors to keep divers out.
That's cool.
We ready?
Mm-hmm.
All right, so infrastructure map of the Hoover Dam site, okay? We are right there, inside one of the diversion tunnels in the Nevada Canyon walls. So the best way to describe this, Hoover Dam was a sequence of events to get it built. And job 1 was to move the water around a construction site. But to do that, they had to blast out 4 of these tunnels out of the canyon walls. 2 on the Nevada side, 2 on the Arizona side. Now they're 56 feet in diameter, but they lined them with 3 feet of concrete. That way that water wouldn't perforate through the canyon walls into the job site. Each one of them, about 3,500 to 4,300 feet in length, about 3/4 of a mile, or about 1.2 kilometers. Took them 19 months to blast them out of solid volcanic rock and line each of them with 400,000 cubic yards of concrete. 19 months, they had 3 years to get it done, so it set that trajectory for finishing it on time. Once they finished it, once they did that, they built 2 coffer dams. Upper coffer dam, 98 feet tall. When they blasted the diversion tunnels, they were about 12 to 15 feet above the water table. So it lifted the Colorado River into these diversion tunnels, moving the water around a construction site. The lower coffer dam, 66 feet tall, prevented water from backfilling into the job site. With those 2 dams, they isolated that area for construction. Once that was accomplished, that area was drained in 135 feet of loose rock and sediment. That was removed to expose bedrock below. 10 tons at a time. They used international harvester trucks. Now they're ready to build the Hoover Dam. So buckets containing 8 cubic yards of concrete. That was what you saw on the film. That was carrying 16 tons of concrete. One of those buckets were lowered via the K-Boys about once every 78 seconds, 24 hours a day, 7 days a week for 1 week shy of 2 years. First bucket on the Hoover Dam, 6 June 1933. Last bucket, May 29th, 1935. So they built the Hoover Dam in less than 2 years. They did the diversion tunnels in 19 months. So again, setting a trajectory for finishing it on time. 6 companies had 7 years to do this. They did it in 5. They had just under 21,000 people work on this, and 96 of them perished. So it came at great human cost.
Are they
And
out there?
What's that?
There's some of them out there?
No, in the dam? No, they inspected every placement, okay? Now, once the dam was completed, they shut down these 3 diversion tunnels to repurpose them. And that allowed Lake Meadowfield, took 6.5 years for that to happen. This one stayed open, allowed water downriver. During the last year of construction, the 4 intake towers were built, and each one of them feed a 30-foot pipe, 2 3/4 inch boilerplate steel. It's a pinstock pipe. And this pipe originates from this intake tower. And it feeds a system of 4 13-foot pipes. That water, as the pipe's reducing, the water builds pressure, slamming into the turbines at 48 miles an hour, spinning in generators. Then they release the water downriver between the U-shaped building and the bottom of the dam. We call that the tail race. When that infrastructure came into play and they were able to release water down here, they destroyed to allow the lower coffer dam to allow water on its natural path downriver. Upper coffer dam intact to this day. At that point, they repurposed that diversion tunnel to become a spillway. 2 spillways built 27 feet below the top of the dam, and quite honestly, they prevent water from going over the dam. So if we have a flood here at Hoover Dam, water approaches the top of the dam within 27 feet or 1205 above sea level, water will preemptively enter the spillways. The spillways are now connected to the outside diversion tunnels, and you can see that angle of approach from the side there. Water will just bypass and release downriver on the outside diversion tunnel exits. Water has never been over the Hoover Dam before, but it has been over the spillways twice. 1941, they tested them. 1983, snow and heavy rain out of the Western Rockies overwhelmed the upper lower basin. Water crested 7 feet below the top of the dam. Water was over the spillways for 63 consecutive days. All right, guys, questions? So inside diversion tunnels, everyone asked about the diversion tunnels. Those house the pinstock pipes from the back intake towers. The front intake towers come in shallow, you can see that, and they exit out the jet spillways on the side of the canyon walls. Anytime they need to do maintenance on the pinstock pipes, they'll release it out there or through those needle valves there.
Those towers are release water back in, those 4 types of towers on the base side.
What about it?
Are those designed to let water go into those tunnels, the bypass tunnels and shoot back out to the bottom?
No, they feed the pinstock pipes. They have 2
Okay.
drum gates that raise and lower, and that just gravity feeds that water into the 30-foot pinstock pipe. And that's how it gets to here. How they regulate rate of flow to these generators, they got 13.5-foot butterfly valves. And those are down there, toward closer to the generators. And then they have a scroll, which reduces from about 8.5 feet to 4 feet, and they got wicket valves in there that rotate, and they work in unison to make that thing spin at 180 revolutions per minute. Anything else? Okay, guys, let's start heading out this way. Now, as you come out here, about 200 feet down there on the lower end of that pinstock pipe, that's where that pipe reduces to that 13-foot pipe. Come on over here, guys. Now that one that goes to the left out there, that goes to Nevada 1. This pinstock pipe serves Nevada 1, Nevada 3, 5, and 7.
Oh, wow. I used to take a picture of the ducks. And the water. And we're running.
The water you see is seepage. 45,000 pounds per cubic foot behind a dam, water find its way. And so it just seeps through the canyon walls. The government spared no expense to keep you dry. Yeah, I get a kick out of this, because when I got out of the military, I said, God, I'm home, because that's how we roll. It's cheap and it works. And all they're doing is just sending it over to this trough and sending it down the river. We don't waste it. And the calcium carbonate, that white is calcium carbonate. It's the same as the ring around Lake Mead. The difference is the sun cannot reach it down here, so it's going to be darker and richer. The green, you see it right behind you there, that's copper. Yeah, and we'll have some red upstairs. I'll point that out as we're walking down there. That's iron. So that's the stuff you'll be seeing here. Hoover Dam is an arch gravity dam. And the arch is really taking the force, weight, and energy and transferring it into the canyon walls. The gravity, the weight of the concrete holds it down, 6.6 million tons. They didn't use any rebar in a dam.
No rebar? Is that what you said?
The only now, historical photos show that they used rebar in the elevator shafts. But that was it, not blocks. Yeah, the blocks were to be separate and autonomous of each other. Now, they did use 582 miles of 1-inch pipe to cool the concrete. But when that was done doing what it needed to do, and that took about 72 hours, they cut it, back grout, and seal it. So everything stayed separate and autonomous of each other. And so as it got built, the blocks were narrow in the front, wide in the back, so trapezoidal in shape, and they ridged them on sides like the roughest potato chip they ever want. Like meat compresses it. The blocks are ridged on the top perpendicular, so the blocks above them would not shift. They became monolithic columns, so they would by overlapping.
Call me to the right, everyone. Watch yourself. I'm mixing it up.
So when it was completed, in any event, you know, the size of the earthquake, the canyon walls, the dam would stay steady, but has the ability to give bend and flex. But there's no structure. 5 feet high, about 40 to 45 feet in length, and it could be 20 to 25 feet in the front, 50 to 65 feet in the back of the dam. Come on in, guys. 2, 4, 6, 10.
Thank you. You now have 11.
Yeah, I know. I got 11. You want to drive this time?
Yeah.
Okay. Right there. Push that switch, push that button.
Good job.
Can we leave them behind?
32 feet in less than 5 seconds. Once we start moving. 5, 4, 3, 2, 1.
That was all.
Damn tour guide.
I love it. Well,
Sometimes it takes 30 seconds for that thing to start moving. Roast me off. Call security. That's okay, guys. Don't worry about it.
I'm sure these were here when I took this tour back in the 80s. Yeah. But I don't remember these little things. I remember this.
That's the canyon walls, and that's how they touch it up there. I know, everyone walks below that, they don't even see it. You got a good job, man, I get to see it all. Come on in, guys.
Oh, very cool.
Yeah, the straight, and the Canadian walls curve.
Alright.
All right, guys. On behalf of Bureau Reclamation, welcome to the Nevada side of the power plant. If you're looking at the commercial grade generators, you're looking downriver. If you're looking to the opposite end or to my right, that's the direction of Lake Mead. And the only thing standing between us and Lake Mead is the Hoover Dam. It's right behind that wall. Hoover Dam stands 726.4 feet tall. Spans across the Pike Canyon 1,244 feet, measuring the top curvature. Top of the dam, 45 feet thick. That allows a 2-lane road over it. But being an arch cavity dam, it's going to be really thick on the bottom. 660 feet thick. Now the visual gun to show that to you. Wall to my right, all the way down to the end of the bay. That's 650 feet, folks. Add 10 feet to that, you've got the thickness at the bottom of the dam. In relation to us, that's 199 feet below us. And as it goes up, it tapers. So at this level, 200 feet up, you got 450 feet of concrete between us and Lake Mead. Downriver, 8 commercial grade generators, 9 on the Arizona side, total of 17. Now they stand 70 feet tall. You only see the top 30 feet of it. The shaft on Nevada 1, you'll see it lit up in the middle there. It's about 38 inches thick, 65 feet long. It extends below that almost 40 feet. Connects to that Francis reactor turbine. That's where the water slams into it and spins the whole operation. Now they rotate at 180 revolutions per minute and generate up to 130 megawatts of electricity. That's enough to power about 65,000 homes. Now when you pull them all together, you won't see that until 5 to 10 o'clock at night because that's when they can sell that power at a higher premium. And when you pull them all together, 2,080 megawatts, enough to power about 1.3 million homes. Now the lights on top of the generators, if they're on, that means that generator's in operation. Now we're going to focus on that rust-colored item on the power plant floor. It's surrounded by a fence. That's a Pelton water wheel. We have that one here in Nevada, one in Arizona. It's horizontally mounted, rotates at 300 revolutions per minute, generates 2.4 megawatts of electricity. That's important to us because they provide all the power that we use here on the site. Station power is what we affectionately call it. So the bridge cranes, lights, elevators, cafe, all powered by the Pelton water wheels. Up top and down the bay are 2 green P&H bridge cranes. Now they span across the bay but have the ability to travel the full length of the bay individually on that rail system you see above us on the top right and top left. They do our heavy lifting for us. Just one of them can lift 300 tons. Yeah, so I like to put that in perspective. One of the bridge cranes can lift the Statue of Liberty. The one in New York Harbor, folks, not Vegas, okay? Come on, kids, be impressed. That was a big deal. Maybe not. Okay, the real Lady Liberty weighs 225 tons. That's impressive, but it's not good enough here. The rotor that you're looking at, I know it looks like we got 7 generators. That's because one of them's sitting right in front of you. And that rotor weighs about 580 tons. And it takes both bridge cranes coupled together working as a super crane to do that heavy lifting. Now lastly, when the Hoover Dam was built, it was built with tourism in mind. It took them 13 months to decorate it and all this Art Deco. And the Toronto marble flooring is a wonderful example of that. It was installed by the Martina family, completed in 1937. Covers 121,000 square feet in the power plant and the structure. Price tag, less than $59,000. That was 48 cents a square foot. That's unheard of today. The decorative inlay, circular one behind all of you there, and I've got a diamond-shaped one to my right. Those were all designed by Alan Tucker True. He took geometrical shapes and he spun that with influence from Southwest Native American pottery art. He infused that to the Art Deco. Circular one, symbolic of water spinning a turbine. The one to my right has an outlet symbolic of power generated by the plant. That's it, guys. That's all I got to tell you. I'm going to put this microphone up and lead you out. Make sure you get pictures before we head out. Thanks and have a wonderful day at Hoover Dam.
Thank you. so he can take a picture. Be very nice.